What up, guys? I'm Texas Sparky, and today we're going to be doing a code talk. Today's code talk is going to be on Article 430. So, Article 430 covers motors, motor controls, motor control circuits, controllers, stuff like that. But I'm just going to go over kind of some of the basis. At the end of the video, we're going to go over and do some calculations on how to size your wire, your OCPD, and your disconnect. I feel like I've talked to the right people. I feel like I've asked the right questions. I have a good idea of what I'm talking about. So like I said, I'm going to try and keep this short, brief. But anyway, the first thing that I want to go over is 430.6A1. 430.6A1 is basically telling us to use our table values. So your table values come from your tables in 430.247 through 250. So it covers DC and AC circuit motors, but that's where we're gonna get like how to size the wire, how to size your OCPD, everything. That's where your FLC is coming from. So it's probably gonna be a lot different than the FLC, or not a lot, but it'll probably be a little bit different than the FLC that you actually see on the nameplate rating of stuff. But don't let that deter you. This is to help you size everything for that specific motor that you're gonna be dealing with. The next thing that we're going to be talking about, and it's what we're going to be talking about at the end of the video, is 430.22. So 430.22 is single motor conductors. So part 2 of 430 is your conductors. So anytime you have a continuous duty load, so 3 hours or longer, you're going to use the 125% rule, and they consider motors under that continuous duty load. So you need to size your wire 120 times 125%. Like I said, we're going to go over this here in a little bit with the calculator and everything and how to write everything down. But just remember, if you're dealing with a motor, it's brand new, you're installing it, you're installing the conduit, the wire, everything, you're going to use 125% for your conductors. The next thing that we're going to roll into is 430.52. This is kind of one of the more important ones to pay attention to. This is the OCPD, so your fuse or your circuit breaker. Most of the time, as far as in my experience, I have seen motors on fuses coming out of a disconnect, seal type, flex, whatever it is, into the motor, into the pecker head of the motor. Yes, they are called pecker heads. That's where you make your terminations. That's usually where your T and S leads are. So anyway, 430.52 goes over how to size your OCPD. So again, you're going to be using your table values out of 247 through 250. So your FLC that you get from your table values, you're going to come over here and you're going to use the percentage that they give you for whatever you're using. So if you're using an inverse time breaker, which is what we use most of the time, it's 250%. And most motors, like I said, are on fuses. So dual element time delay fuses, 175%. Those are going to be your two big ones. Also, when you look in here, you're going to see the first two lines are exactly the same. That's because those are for AC circuits, single phase and three phase. And don't get confused because the code book calls them polyphase, but polyphase is just more than one phase. So in our world, more than likely it's just going to be a three-phase motor. And then the next one that we're going to be talking about is 430.110A. So 430.101, part 4 of 430 is your disconnecting means. So that's going to be your location of the disconnecting means, the controller, stuff like that. It goes into all of that. But 430.110 is the ampere and interrupting rating of the disconnect that you're going to be dealing with. And this tells us that we need to times it by 115% of our FLC. Well, the problem with this lies is you could have a 100 amp, say you have a 100 amp FLC. Well, if you times it by 115%, and it comes out to, it's going to come out to 115 amps. Well, the lowest percentage that you're using whenever you size your fuse or your circuit breaker is 175%. So the problem kind of lies whenever you get into your higher ampere ratings, As far as the lower stuff, you're probably going to use a 30, a 60, or 100. Those are your three main ones you're going to use, but they make much bigger disconnects, and you can eventually get into those. Like I said, those are the 3 or 4 main bulletin points that I kind of found helpful in the code book. Now we're going to go into our tables. So like I said, I have a made up scenario here written on a piece of paper. My sheet is blank. I made this scenario up. I have not sized this motor. I haven't done anything like that. So I'm also going to be doing the calculations with you guys, so that way you see it firsthand, you get a better idea of it, and hopefully it helps you out in the field someday. So anyway, whenever you flip in your code book to 430 it's going to be 332. If you're looking at the page number at the bottom, it's going to be 70-332. And this is where your squirrel cage induction motors are. So if you guys don't know, squirrel cage induction motors are your most popularly used motors in our industry. So, and now we're going to go into the sizing of all of this. So for this, I kind of chose even numbers, rounded everything up. So today we're going to be dealing with a 3-phase 460 50 horsepower motor. Now, if you hear somebody tell you that the motor is rated for 230 or 460, that doesn't mean that you need to start looking into getting a different transformer, or you need to start, messing with the transformer that's already available, trying to get different output powers, because 230 is basically 240, 460 is 480. That's all it is. I haven't looked into it. I haven't researched why they put those numbers, but that's just what they put. So anyway, the first thing that we're going to do is we're going to size our wire. So like I said, these motors are continuous duty, 3 hours, 125%. So you're going to get your calculator and you're going to come and you're going to find what voltage and what horsepower. That's how you're going to cross-reference everything to find your full load current, full load amps, whatever you guys want to call it. So for a 50 horsepower 480 motor, it's 65 amps. So you're going to take that 65. Whenever I'm doing calculations like this, whenever I was doing homework for it, I would write 65 at the very top. That way I never had to go back to the code book and look. I could just reference the top of that. So I'm going to do that here. I'm just going to write 65 amps. And I'm going to use that 65 for all of these calculations down here. Also, I forgot to tell you guys, but the disconnecting means is going to be a disconnect. It's going to be time delay fuses, so dual element time delay fuses. Sorry, I was looking for the right words there. But anyway, so 65 amps, and now we're going to size the wire. So like I said, continuous duty, 125%. So on your calculator, 65 times 1.25. So you come out to 81.25. 81.25 is what our amperage is, or what our 125% is. And now this is where you're going to be flipping back and forth in between your code book, between different articles and different sections of 430. So now that we have this, now we're going to go back to 310.16. And I always size out of the 75 degree column. I know some people do it out of the 90 degree column and all that stuff, but 75 degree, I feel like just kind of covers it. You're not, you're not overdoing it, but you're also right in between. And most of your terminations are going to be rated for 75 degree. Anyway, so we have 81.25 amps. Well, 81.25 is not an ampere rating of any wire. So we come down here and we find number 4 wire is rated for 85 amps. Well, that covers us under 81. So our wire size is going to be number 4s. All right, and the next thing we're going to size is our OCPD. So, like I said, you got that 65 number up there, keep that 65 number. So, 65 amps, and I said we're using dual element time delay fuses. So, like I said, flip right back into 430.52, and this is where you're going to find your percentage. So, dual element time delay fuses, 175% for both single phase and polyphase motors. So we take our 65 amps and we times it by 175%, so 1.75. And that comes out to 113.75. Well, 113.75 is not a standard ampere rating of a fuse or circuit breaker, anything. So in our code book 240.6a, you have a table of standard ampere rating for fuses and inverse time circuit breakers. Right here it gives you all the standard ampere ratings. So you can go into a CED, wholesale, Elliott, whatever you got, whatever supplier you guys are having, and you can say, I need this size fuse. So like I said, 113.75, that's not a standard ampere rating, but 430.52 exception 1 allows us to go to the next size up, which the next size here would be 125 amp. So 125 amp dual element time delay fuses. And if you guys are curious why we use dual element time delay fuses on a lot of our motors, is because of the inrush current. The inrush current typically on a motor is 6 times greater than what the FLC is. There is a way to calculate your LRA or your locked rotor amps. That's just basically what the starting current of the motor is. Also, if you have a certain code letter or type, it's in the code, the A, B, C, and D's. You can look in the code book on the back side of the 430.250, and that'll give you what your LRA would be for a ABCD type motor. Anyway, like I said, back to the OCPD. We're using 125 amp dual element time delay fuses. And now this is where the code I feel like it kind of confuses people if you haven't experienced it a whole lot. But if you remember 430.110a, the ampere and interrupting capacity, it tells us that we have to times our FLC by 115% to get the disconnect. Well, if I times 65 by 115, so 1.15, I get 75. Well, that would mean I could use a 100 amp rated disconnect. Well, I can't do that because I have 125 amp rated fuses. So I have to go up to the next size, which would be a 200 amp. So that right there kind of, I feel like to me it could confuse somebody if, you know, a person, say a purchasing person or somebody that hadn't experienced any of this and wasn't very familiar with the code, and he just looked in there and said, oh yeah, 115%, order 100 amp and order 125 amp fuses, not even thinking about this, it could cost a lot of time and money to a customer, to the business, or so on and so forth. But anyway, so the disconnect that we're going to be using in this scenario is a 200 amp. 200 amp. So right there you have 125 amp fuses, you have number 4 wire being terminated, and you have a 200 amp disconnect. Now a 200 amp disconnect might be big, but that's the next available size for the fuses that you've selected. And a lot of times you can change the type of fuses that you're using, you know, S fuses, I think there's Edison, all different kinds and stuff like that. But this should help you guys and give you kind of a basic guide on what to look for, what to expect. If you're ever installing a motor, or even if you're troubleshooting one and you see it says 84 amps and they're using number 6 wire, you go, well, hey, maybe we should look at this, you know, wire does like a little chart or something, maybe we should change the wire. Again, I hope this helps you guys. I'm going to be coming out with more of these videos. This video will be on my YouTube. Thank you guys again. I appreciate it and hope you guys have a good night.